Okay, so I'm Tim from Insomnia, or Pruby, and I'm going to be talking today about Ruby on Rails, and in particular some of the issues we see in Rails and similar frameworks, and how that differs from our standard PHP application that we scan and find a million issues in. So my name's Tim. I'm a pen tester at Insomnia, so I spend my days getting given an application, breaking into the application, and writing a report at the end of it, hopefully. My background is in software development, and specifically I spent quite a few years writing Rails applications. So I tend to approach pen testing very much from the software source code point of view. There's a lot of variation in how people approach a pen test, varying all the way from I don't want to look at code to I want the code before I look at anything else, and that's kind of the end I tend to sit on. If you want to know something a little more personal about me rather than work, in my own time I dance West Coast Swing, and in about a week's time we're starting our own school in Wellington. So I would say most web applications as pen testers that we come across, we test in pretty much exactly the same way. We take the application, we find all of the various endpoints, all of the things we can do, everywhere we can put input. We capture samples of what normal looks like. So when we are using the application normally, what requests are sent from our web browser off to the server, what's the normal use case, and then we try to manipulate those requests. We try to make those requests contain content that wouldn't be normal to achieve a desired result. And that desired result might be your traditional cross-site scripting type flaw, has very well defined, I put this in the box, this type of thing comes out. Or it could be a SQL injection attack, whatever. But we follow a very fixed process of we find the endpoints, we alter what we put into them, we try to achieve a certain outcome. Now, I hear people say a lot that when they're testing Rails applications or other applications built on a strong underlying framework, that they just don't find as many bugs. So you'll hear people go, I don't find bugs in Rails apps when I test them, I don't find bugs in ASP.NET apps when I test them, because when you're doing this, the framework itself is setting a consistent way of going about writing your application. It's not that you get to make all the choices for yourselves. It's that you subscribe to the framework's way of doing things, and in return it gives you certain things automatically. It might give you authentication, session management features automatically. It might give you protections against certain security issues automatically. So we can, in a framework like this, deal with a lot of the common security issues without the developer necessarily being aware of them, or without the developer taking active steps to prevent them. However, the point I want to get across is that frameworks don't just take away attack surface, they also add a whole series of different attacks of their own. I admit I stretched here somewhat for alliteration, but I see this as a bit of a spectrum. We have at one end the process of rewriting everything from scratch all the time. That's the very manual process that we follow. And you might see this if someone wrote a PHP web app with no framework behind it, right? They're just going, take the input here, put it out on the page here, and they write everything from scratch. There are the things that we kind of can't get away from, the things which we always have to write in an application because they vary with every application. I've called that the mainstream, that's where I'm stretching the most. And then there are the kind of magical things. There are the things the framework does for us, the things we don't have to write, that the framework just handles. And we end up with different gaps at each end of the spectrum. At the manual end of the spectrum, we probably, as a developer, understand what we've written, but we miss the things we don't know we needed to write. At the other end of the spectrum, we have the magical things the framework does for us, and we don't need to be aware of the things we didn't know we needed to write to the same extent, but we also, by not knowing what it's doing for us, expose ourselves to risks through that misunderstanding. An example of the things that sit in the middle there, that we always have to do in every application would be, for example, authorization. We had a talk about that earlier in here. There are frameworks for helping with authorization, but fundamentally it's something that you can never avoid thinking about. Every application has a different set of rules about who is allowed to access what, and you need to specify those rules in some form. There is always going to be a place where you can get the rules wrong, and as a result someone will be able to do something they weren't supposed to be able to. And there will be ones that make it a little easier to see your rules all in one place, but that's a fundamental. In a more general sense, we get into the business logic type issues that you have in a web application. Every web application we build has different business rules behind it. If we only had one set of rules, we would have one universal application, everyone would use it. But yeah, we'd rather not do everything in Excel, right? So every web application has a different set of rules, and we need to remember to enforce these. The framework can't help. You will always, regardless of what a web application is written on, have to be aware of these issues. So we get into some of the things that frameworks start to do for us. Now, this is an example of a Rails template, and I'm taking a simple piece of input, in this case I've called it warning, and I'm sticking it into a page. Now, if I did this without any thought in most languages, most environments that don't have this automatic protection built in, this would result in a cross-site scripting flaw. On the other hand, in Rails, this would be protected by default. By default, everything is escaped going into an HTML template so that you can't inject HTML. On the other hand, we sometimes need to bypass that. We sometimes, for example, are trying to, instead of inserting HTML content in a page, we are trying to insert something inside a bit of JavaScript. In this case, a developer might assume that JSON dumping something always makes it valid JavaScript, and therefore I can drop it in here with no escaping. This assumption is false. If you include the expression open angle bracket / script inside the JSON, then you end up with a cross-site scripting vulnerability. So the protections are never absolute. We always need an ability to override them. When we override them, we will always have a risk of introducing an issue. The other thing that the magical features of a framework can do is add additional attack surface that we might not as a developer want or be aware of in any way, shape or form. So Rails has a really complicated input model, which is if I send an HTTP request that looks like this, it's torn apart, turned into pieces, and turned into an abstract idea of a request, which is I have the foo parameter is equal to bar, and or the foo parameter is an array of zig and zag. There is a whole series of different automatic ways in which Rails will carve up a request you send to it and call the application with the parameters you've passed. And it's often possible to pass things which a developer was never expecting to an application. Another example of this is I've actually slightly mistyped that, it's X HTTP method override header, which you can send to a Rails app. Now, when this feature was first introduced, Rails was being deployed on a lot of web servers which only supported get, post, head requests, which are 3 types of HTTP requests. They went, we want to be cool and hang with the rest kids, so we want to add delete, we want to add put, we want to add create verbs, additional HTTP verbs that the servers didn't support. So to accomplish this, what they did is they added the idea of you can pass an extra parameter or an extra header that says, even though this is an HTTP post request, treat it like a GET request. And as far as the application is concerned, it sees a GET request. As far as the code you as a developer are writing, it sees a GET request. Again, a GET can be interpreted as a post. A GET can be interpreted as a create or a delete. And so if you're writing a web application firewall or something like this that sits in front of a Rails app, you can imagine that if you filtered on post requests to blah in your web application firewall sitting out the front, Rails' input model has just subverted that for you. An attacker can instead send a GET request as far as you're concerned and still get to the issue. A common result of this complicated input model is type confusion attacks. So Ruby, for those who haven't written it, is a dynamically typed language. I don't say everywhere through my code, this is a string, this is a number, this is a list. I allow anything in the application to be, for its type to be determined as the code is being evaluated. It's not something that I do when I'm compiling it. So I don't have to say this is a string, it could be a string, it could be a number, and that often hides an assumption. So as a developer, I'm assuming this is a number. What if it's a list? As a developer, I'm assuming that this is a string. What if it's a dictionary or a lookup table? So there are no automatic type checks built in like this, but methods inside it often vary their behavior. So take as an example, this is something I completely pulled out of the blue, haven't worked with them. Has anyone used the White Pages app? You go in, you type someone's surname, you type the city they're in, and it brings up phone book records, right? They don't want someone going through and scraping the entire phone book. So they want to have, you have a limit of this is how many requests you can make, and each time you have to specify a surname and a city. Well, if I tried to re-implement this in Rails, I might write the code somewhat like that. Find entries with a surname of this and a city of this. But if I pass a list of cities, or if I pass a list of surnames, I'm going to end up with a database query that looks like that. Because Rails' database layer will go, oh, you've given me an array. I know what you want to do with that. You want to find something that matches any of these. It varies its behavior based on what type of parameter you gave it. So in this example, I would find Smiths, Wrights, and Carters in Auckland, Wellington, and Christchurch, which is going to be, in one request, a significant chunk of data. You can imagine that this could be used not only to bypass limits or rate limit type things, it could also be used to dump large quantities of data. It could be used for denial of service attacks. Imagine that it takes you a significant amount of effort to process each result from something. If I have M cities times N surnames, I'm getting you to do M times N work. Another aspect to this is once we subscribe to the philosophy of I don't want to write things myself, I want to drop things in, which in general is a really good philosophy, we start using the same components again and again and again. And these often contain known flaws. And if we don't pay attention to what those known flaws are, we can end up introducing flaws into our application that other people know about that we don't. So as an example, the devise framework, which everyone writing Rails apps uses if they want to have a basic login prompt, username, password, blah, 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 it just handles all of that for you really nicely. That framework contains user enumeration flaws. It's easy to identify whether or not users exist and who your users are in the application. As a result, that might be entirely unsuitable for some use cases. I worked a while ago, for example, on a gas market where a core requirement was that the identity of the participants be confidential. So it was a significant issue to us that devise could tell you whether or not a user existed, even though in normal cases you might not care. And they've made an entirely valid decision to treat that as a feature, not a bug. Another example, the paperclip framework. A couple of weeks ago, security issue was published in the paperclip framework, which to my embarrassment I've known about and been using for the last year, because this was a feature where you could say, paperclip allows you to attach attachments, upload attachments and put them onto things. So attach them to someone's profile. I want to upload a profile image, something like that. If you fail to apply the right filtering, what you can do with paperclip is say, instead of me uploading an image, can you just go and get it from here, please? Now, people were using this to say, can you just go and get your Amazon EC2 instance metadata, including all your keys, thanks, and give it back to me? And so, we've used this in a number of pen tests over the last year. We went, it's a feature, not a bug, they're not going to be interested. Turns out they were interested a few weeks ago. When everyone thinks of Rails security, mass assignment is the first thing you'll hear them say. The truth is it's not much of an issue in Rails apps anymore because they've kind of dealt with this in most cases. So mass assignment bugs are a case where I do this. I want to update an account. Give me a bunch of fields, I want to update those fields, right? So the normal case looks something like this. I want to update my account, I want to set my name to Tim Goddard, and I want to set my telephone number to that, right? But what if instead of passing that to the application, I pass that? I want to set my balance to $1 million, thank you. I want $1 million. Well, then that's the equivalent of writing this, and because it didn't filter which attributes I was allowed to change, my balance is now $1 million. So mass assignment is what everyone thinks of in terms of Rails security. We've been through a bit of a series of different mitigations in the past. The earliest mitigations were not sufficient. The next iteration were not sufficient. The iteration after that were also not sufficient. And we're kind of finally in a good place where you actually have to deliberately stab yourself in the foot to get these issues now. But I should say while people think of this as being synonymous with Rails, it's not just Rails. I've seen this in an ASP.NET application only a month or two ago. Another common issue in Rails applications is that when you create a Rails app, it creates a bunch of code for you. It generates a bunch of code automatically, and so you might have, for example, I want you to create a way of viewing my account information, and I want you to have a profile page. Well, it turns out in the default code, if I stick .json on the end of that, I'm asking it to give me a JSON version of the user's profile instead, and if I've left the code in its default state, I could end up with something like that. So it's really important in a Rails app to be aware of all of those things that have been generated automatically for you, and in particular, and again this is something a mitigation has just been introduced for Rails 5 but yeah, this is something to be aware of. And yes, it's not usually this simple, but occasionally happens. Another thing, and I gather the next talk in this room is going to be on race conditions. The race conditions are a real problem in Rails applications. There's a fundamental reason for this. Rails developers want to write Ruby and nothing else. They do not want to write stored procedures in a database, because that means learning and writing a whole different language. That means building an entire separate set of code which you have to manage and deploy separately, right? You could have those being out of sync. It complicates the whole process. Whereas if you put all your checks, all your code in the Rails app, then it's all in one place. It's all in the same language. Unfortunately, the application server isn't inside the database. It doesn't provide the same guarantees of atomicity, so on and so forth, that mean that database updates always, you read a consistent set of data, you make a series of decisions, and then you write a series of changes which all happen at exactly the same point in time. You don't get that on the application server. And a classic example of where this could go wrong is, say I've got a person and I say, I want every person to have a unique card number. So it's an access card to swipe into a building or something. Now a company has many people and I want to be able to update people in bulk, is basically what those mean if you're not a Rails dev. The combination of these features, the ability, saying on the one hand I want to check in Rails that the access card number is unique, and on the other hand I want to allow bulk updates, actually introduces it's not even a race condition, it's just if I do a bulk update, it fails to check the uniqueness rule. It checks the rule against the database and then inserts a whole bunch of records at once. Anyway, race conditions are pretty easy. I'd say I haven't done too much with them, but you will learn about them from the next talk. Despite the fact that this is a framework that supposedly provides us with a better standard of security, and genuinely writing applications on opinionated frameworks does result in a better standard of security. Despite this, there is a surprising amount of rope to hang ourselves with, right? This is a really easy way to ruin your day. People used to do this all the time until a bit more awareness developed about how dangerous it was. YAML is a serialization format, right? If we load in YAML files from an untrusted source, it results in remote code execution through a deserialization attack. And there are standard attacks that will work against any Rails application regardless of what custom code you have written. If you're doing this, remote code exec. Marshall is the other format that's particularly dangerous. Another another type of attack that can end up as remote code execution is a really common feature in Rails is I've got the idea of scopes. I want to have the active accounts, I want to have the inactive accounts, and so I want to be able to call the active method on the account list to get the ones that are active, right? People often write, I want to list active accounts, they'll write something like that. The problem is, if I say I want to list the delete accounts, then it calls the delete method, resulting in deleting a whole bunch of data. And this can, under the right circumstances, end up with everything up to and including remote code execution. Another example, remote code execution via inline rendering. This is a feature of Rails that lets you, instead of storing a template file, just pass it a template as a parameter, right? So you can build your templates on the fly in the application and use them like this. Not many people actually use this feature, except there was a framework for pen testers called Phishing Frenzy, which was designed for testing people's responses to phishing emails. So I had a bit of a look at it and found this. It would go and copy someone else's site and then render it as a template. Well, I could stick Ruby code in a site. If someone else copied my site, then I'd have remote code exec on their server. I believe that they have completely abandoned this project because they have failed to fix it after more than a year. So I could pass a template like that, rmrf/, and just destroy everything. Another example, this would be an arbitrary file read anyway, but I accidentally wrote this into a competition that I was going to run for my colleagues and realized at the last minute, crap, that's going to be way too easy, because it turns out that in Ruby you can do this funny thing that it inherited from Perl, and whenever you're opening a file you can stick a pipe character on the front of the file name and it will run everything else following it as a command. And then the output is returned as the file output, right? I've never ever seen anyone actually use this for legitimate purposes in Ruby. It's just something it's inherited from its history in Perl. I've seen it's classic Perl CGI bug. I have also, unfortunately, had the pleasure of seeing eval used as a serialization format in a production financial application. Just, if you're doing this, you probably need to go back and revise the basics. Before I end, I just want to say, one thing that people grumble about sometimes with Rails is that major versions roll along fairly often. You know, there's Rails 2, then there was Rails 3, then there was Rails 4, then there was Rails 5, and every time there's a major version increase, every time we go from 3 to 4, 4 to 5, so on and so forth, you have to go and migrate your application. You have to take the code that you've written and actively go and change it to match the new conventions. And people grumble about this and they take shortcuts doing it, but this is how Rails genuinely starts to provide better security over time for developers using it. If you look at, PHP, PHP has massive attempts at backwards compatibility so that you can run a PHP app on something that was written 15 years ago. So you can run something that was written 15 years ago on a PHP server today. It doesn't make breaking changes, and this severely compromises its ability to introduce automatic protections, automatic controls for you. On the other hand, people do take shortcuts when they upgrade. If someone has previously written a Rails application on Rails 3, and they upgrade it to Rails 4, they could well have turned off the new security features rather than actually altered their code to suit. So something that's worth being aware of is what was this originally written for, and check that things have been migrated properly. So I just wanted to end this on a more practical note, because I've gone through a whole series of issues and basically given you a big list of problems, right? And that doesn't tell you how to actually go out and fix any of those things. It's a bit of a, oh, I need to pay attention what might come up, but it doesn't tell you how to go out and actually fix all of these things in practice day to day during your work. So I just want to say, if you're a developer, I really want to encourage you to pick up a couple of security tools. For Rails in particular, Brakeman is a fantastic static analysis tool. It takes your code, it looks through all your code, it does analysis on a bunch of your endpoints and a bunch of your code, a bunch of your methods, and it says, does this look like a vulnerability? It can't always tell you 100%, but it says, does this look like a vulnerability? And it finds a whole lot of things. Please don't ignore the findings. I have previously gone to someone with people, some of whom are probably at this event, who had ignored a warning about command injection. Surprise, wasn't a false positive. It just required a little hurdle, and then there was complete compromise of their servers as a result, right? Don't ignore the findings. Even if you don't think it's a security issue, treat it as an opportunity to improve. Bundler audit's another one. This is really good for, in a Rails application, a file called your gem file contains a list of all your software. This goes and checks all the versions for known issues. Really good for dealing with those components with known vulnerabilities. And beyond that, your real focus needs to be on those common elements, authorization issues, business rules, because those are where the framework can't help you. Rely on the security tools for the technical stuff, focus on your business rules, because that's where you're going to get bitten. If you're a tester, as well as doing all of those things, because I expect you to go a bit further than the developers are going on their own, you're the specialist, I would really recommend white box reviews. Even if you are at the end of it, even if you come from a networking background, you've never been a coder, you don't like working with the source code much, at a minimum, getting the code will provide you with the ability to run the tools at the top there, which will give you starting points. And there's one file in every Rails app, config/routes.rb, that will give you a list of all the endpoints. So even if you don't really want to read the code, this gives you a really good starting point for the rest of your testing. And as a tester, hunt the manual things, the things people have written they should have relied on the framework to do, and hunt the magical things, the things that people have relied on the framework to do and haven't understood. So as a developer, focus in the middle. As a tester, push to the outsides there. Thank you. That is me.